Hi everyone, welcome back. In this video, we continue discussing frequently asked scenario-based Java interview questions with answers and code examples. Let's start with the first one. You are designing a payment system. When would you use an interface instead of an abstract class? Now imagine this is a real project. You have multiple payment options: card, UPI, net banking, maybe wallet. What do all of them have in common? They all can perform a payment. They all can perform a refund. That's a behavior contract. But do they share the same internal logic or fields? Usually no. Each one talks to a different gateway, different API, different validation rules. So what we really want is not shared implementation. We want a rule that says every payment type must support pay and refund. That is exactly what an interface gives us. It defines what must be done, not how it is done. And here is the important architectural point. If tomorrow your card payment also needs to implement something like auditable or retriable, it still can. Because Java allows implementing multiple interfaces. But if you had used an abstract class already, you would lock the design. So in interviews, say this clearly. Use an interface when you need flexibility, multiple implementations, and no forced inheritance hierarchy. Now let's quickly see the code so that you can clearly understand the scenario. First, we create an interface named payment method. Inside it, we declare two methods, pay and refund. Then we create a class named card payment. Card payment implements payment method, so it must provide implementations for pay and refund. Next, we create another class named UPayment. Again, it implements payment method and provides the same two methods. Now in main, notice something important. We create a reference of type payment method, not card payment. That means our calling code depends on the contract, not the concrete class. So we can switch from card payment to UPI payment without changing the rest of the system. That is exactly what interviewers want to hear. Now, let's look at scenario 2. You need to prevent inheritance of a class. How would you design it? This one is straightforward but very important in real projects. You simply mark the class as final. Now the interviewer usually expects you to explain why you would do that in real projects. Because sometimes you don't want anyone to change your logic by extending the class. Think about a security token class used in authentication. If someone extends it and overrides validation logic, they might accidentally break security rules. By marking the class as final, you make sure the behavior stays exactly as you designed it. This is compile time protection. The compiler simply won't allow subclassing. Now let's walk through the code. We create a class named security token and we mark it final. Inside it, we keep token value as a private final field. So the token value cannot be changed after object creation. We create a constructor that validates input. If the token value is null or blank, we throw illegal argument exception immediately. Then we provide a simple getter method. And in main, we create the token and print it. The key interview point is this. If anyone tries to extend a security token, the compiler stops them. So we prevent inheritance at compile time, not at runtime. Now let's look at scenario 3. Two classes share 70% common code. What design approach would you use? This is where many candidates give a generic answer like inheritance. But in interviews, you should answer like a designer. First, figure out what kind of common code it is. If both classes follow the same overall process, same sequence of steps, and only a small part changes, then template method pattern is a perfect fit. A simple real example is report generation. PDF and Excel reports follow the same flow. Load the data, format the data, export the report, Loading and exporting are common. Formatting changes. So we create an abstract base class that defines the full flow. We keep the algorithm steps in one place so the process stays consistent. Then we allow subclasses to customize only the step that varies. Now let's walk through the code. We create an abstract class named ReportGeneratorTemplate. Inside it, we create a method named generate. And we mark it final so subclasses cannot change the order of steps. Inside generate, we call three methods: load data, format, and export. Load data is common, so we implement it in the base class. Export is common, so we implement it in the base class too. Format is different for each report type, so we keep it abstract. Now we create PDF report generator and extend the template. PDF report generator overrides only the format method. Then we create Excel report generator and do the same. In main we create one object and call generate. The full algorithm runs in the correct order. And only the formatting step changes based on which subclass you choose. This removes duplication and keeps code clean.